Hello everyone, this is Dr. Arjyadhara Pradhan. I'm going to speak today regarding energy audit instruments. In energy audit and accounting, or we can say energy audit and management, energy instrument play a crucial role because while measuring different electrical parameters, non-electrical parameters, these instruments comes into the pictures. May it be electrical parameters like in terms of your voltage, current, wattage, power factor, we require several electrical instruments like voltmeter, ammeter, wattmeter, power factor meter. And similarly, for non-electrical measurements like your flow meter, we require solar meters, we require combustion analyzer, we require anemometers. So there are several parameters which has to be monitored during energy audit and management. Now these measurements helps the auditor to make out how to achieve energy efficiency, how to conserve energy, which parameters need to be focused, which parameters are going beyond limit. So these instruments we will be studying which instrument is used for what purposes and a variety of instruments. Let me share my screen so that we can go to directly to the PPT and we can see the different instruments. Okay, I think my screen is now visible to everybody. So we will be starting with energy instruments. Now, energy audit, let me give a brief introduction to an energy audit. Energy audit is an official survey or study of the energy consumption, and its objectives are to recommend steps for improving efficiencies, reducing energy cost and wastages, improving quality. Now, the requirement of an energy audit, such as identification and quantification of energy, necessitates various measurements, and these measurements require the use of instruments. The parameters generally monitored during the energy audit may include basic electrical parameters in AC and DC system and the parameters of importance other than electrical like temperature, heat flow, radiation, air and gas flow, liquid flow. So basing on these, there are four basic group of instruments. So we have electrical measuring instruments, temperature measuring instruments, pressure and flow measuring instruments, and we have some miscellaneous instruments. So let us go to electrical measuring instruments. So these are instruments for measuring major electrical parameters such as kVA, kilowatt, power factor, hertz, kVAR, ampere, and volts. In addition, some of these instruments also measure harmonics. So there are instruments which will be measuring harmonics, and these instruments are applied online on running motors without any need to stop motor. Sometimes instantaneous measurements are done by handheld meters by using those meters like a clamp meter, clamp meter type ammeters, clamp meter type voltmeters. Similarly, we have multimeters, so those are all handheld meters. While more advanced one facilitates cumulative readings with printouts at specific intervals. In those meters are already inbuilt on the system so that they will give a record of the reading continuously. Now we'll go to voltmeter. So voltmeter, as its name suggests, it is used for measurement of voltage on an electrical equipment, and it is generally connected in parallel. The main principle of voltmeter is that it must be connected in parallel in which we want to measure the voltage. Now parallel connection is used because a voltmeter is constructed in such a way that it has a very high value of resistance, so that the high resistance is connected in series, then the current flow will be almost zero, which means the circuit has become open. Now if it is connected in parallel, then the load impedance comes parallel with the high resistance of the voltmeter, and hence the combination will give almost the same the impedance that the load has. Also in parallel circuit we know that the voltage is same, so the voltage between the voltmeter and the load is almost same, and hence the voltmeter measures the voltage. There are various types of voltmeter like permanent magnet moving coil voltmeter, moving iron voltmeter. We have electrodynamometer type voltmeter, rectifier type voltmeter. Then we have induction type voltmeter, electrostatic type voltmeter, digital voltmeters. Then we have DC voltmeters, AC voltmeters. So these are different categories of voltmeters which are used in the industries, in the laboratories, and for different purposes. Then comes to ammeter. Ammeter is used to measure current, we can say. Ampere meter, we can say. Now, ammeter means ampere meter, which measures ampere value, current value, that is. Ampere is a unit of current, so an ammeter is a meter or an instrument which measures current. Now, these are very useful instruments for measuring current in wire without having to make any live electrical connection. The figure shows a clamp meter type. Whichever wire we want to measure the current, we will just put the clamp across it so that we will get the reading on the screen. The clamp is opened up and put around one insulated conductor, and the meter reads the current in that conductor. The main principle of ammeter is that it must have a very low resistance and also inductive reactance. If the resistance will be more, then current will never, definitely there will be obstruction to the flow of current and it will not show the exact reading. So it should have very low resistance which will allow sufficient current to flow through this. Again, there are like this and like voltmeter, there are different types of emitter. We have a permanent magnet moving coil emitter, moving iron type emitter. We have electrodynamometer type emitter, rectifier type emitter, DC emitter, and AC emitter. Then comes wattmeter. The wattmeter is an instrument for measuring electrical active power. You can say in watts in any given circuit. And again, there are different types of wattmeter, like induction type wattmeter, dynamometer type wattmeter, which is based on dynamometer effect. Dynamometer effect. Then you have induction type is further divided into shunt magnet and series magnet. Now, wattmeter can be a unit upper power factor wattmeter, or it can be lower power LPF, like low power factor wattmeter also. Now, application of wattmeter. The wattmeter is widely used for measuring and debugging electrical circuits. It is also used for measuring power being distributed and transmitted. Then utility frequency are measured using an electromagnetic wattmeter. Even they are also utilized in software industry to access the power capacity and energy usage of electrical items. Now they are used to gauge the power rating of appliances like refrigerators, electric heaters, and other machinery. Now for a particular object, these wattmeters are employed in a variety of laboratories. So this shows that there are different applications of wattmeter. Next type of instrument which is used in the energy audit is multimeter. Multimeter is a very useful instrument because in one instrument or in one device we can measure voltage, we can measure current, we can measure frequency. So we have different settings for this so that we can go for different functions. There are probes are there which is for a common and for a live wire. So they measure ampere, electron flow, volts, electrical pressure, and ohms resistance of the electrical equipment. Now, multimeter, particularly the digital clamp-on designs, are considered more versatile audit instruments, and they measure from the range like 0 to 300 ampere for current, 0 to 600 volts for voltage, and 0 to 1000 ohm for you can say resistance. By using rheostat, we can vary the resistance, but we can measure the resistance by the help of multimeter. So mostly for measuring resistance also multimeters are used. Next, we have power factor meter. Power factor meters are used to measure the power factor of electrical equipment, particularly three-phase motors. Power factor is a measurement of electrical current in a wire, which is doing useful work compared to the total current in the wire. Then tachometer, the name suggests the speed of any kind of motor can be measured by the help of tachometer. And we know that the speed changes with frequency, belt sleep, and loading. A simple tachometer is a contact type instrument which can be used with the direct access is possible. Now, next category of instrument is temperature measuring instruments. So, in industries, boilers are at very high temperature. Even many machineries, many operational devices, they operate at very high temperature. So, it's very necessary to measure the temperature frequently so that hotspot formation or sometimes when the temperature goes beyond the range, there might be chances of burning, there might be chances of blast. So, temperature measurement is very much highly essential for audit purpose. So, temperature measuring devices are generally needed to measure temperature in offices, worker areas, and operating equipments. Knowing process temperature allows the auditor to determine process equipment efficiencies and identify waste heat sources for potential heat recovery programs. Now, some common types include an immersion probe type, a surface temperature probe type, a radiation shielded probe for measuring true air temperature. Even thermometer is a simple type of temperature measuring instrument. We have RTDs. So there are various types of temperature measuring instruments used in the industries, in the laboratories, and these are required for energy audit and management. Now, the first category is contact thermometer. So, these are the thermocouples which measure temperature of flue gas, hot air, hot water temperatures by insertion of probe into the seam. So, directly the probe has to be in contact with the hot objects where the temperature needs to be monitored. For surface temperature, leaf type probe is used with the same instrument. Then there are non-contact type thermometer where the temperature is very high, it's not possible to touch it. There we go for non-contact category. So infrared thermometers are used for those purposes. An infrared thermometer is a thermometer which infers temperature from a portion of the thermal radiation, sometimes called blackbody radiation emitted by object being measured. They are sometimes called laser thermometers or non-contact thermometers also. By knowing the amount of infrared energy emitted by the object and its emissivity, the object's temperature can be determined. Now, uses of infrared thermometers. There are a variety of uses of infrared thermometers like detecting clouds for remote telescope application, checking the mechanical equipment or electrical circuit breaker boxes or outlets for hotspots, checking heater or oven temperature for calibration and control purposes, detecting hotspots or performing diagnostic in electrical circuit board manufacturing. Then you have checking for hotspot in firefighting situations, monitoring materials and process of heating and cooling for research and development or manufacturing quality control situations. So these are some of the listed uses of infrared thermometers. Now we have pressure and flow measuring instruments. So these are used for measuring airflow from heating, air conditioning, or ventilating ducts, or from other sources. Now, airflow measurement devices can be used to identify problems with airflows, such as whether the combustion flows into a gas heater is correct or not. So first category we have pitot tube and manometer. So air velocity in ducts can be measured using a pitot tube and inclined manometer for further calculation of flows. Then we have anemometers. Anemometers are cup-shaped devices which are used to measure the wind speeds. Mostly these are installed in wind instruments like you can say horizontal axis wind turbine and vertical axis wind turbine to determine the wind velocity, wind direction, wind speed. And wind vents are mostly used to determine the direction and speed is used to determine by the anemometers. So there are two types of anemometers like vent type and hot wire type. The volume of the air moving through an orifice can be determined by estimating the free air of the opening and multiplying by the air speed. So this result is approximate due to difficulty in determining the average air speed and the free vent area. Now we have another flow meter, that is water flow meter. So this non-contact flow measuring devices uses Doppler effect, or we can say ultrasonic effect. There is a transmitter and the receiver which are positioned on opposite sides of the pipe. The meter directly gives the flow, and water and other fluids can be easily measured by this water flow meter. Then there are simple flow meters which are used to measure the flow of liquid and gases, and they are also used to control the rate of flow if they are equipped with flow control valves. Next, we have ultrasonic flow meter. Ultrasonic flow meters are commonly applied to measure the velocity of liquids that allow ultrasonic waves to pass, such as water, molten sulfur, cryogenic liquids, and chemicals. Now, transit time designs are also available to measure the gas and the vapor flow. Ultrasonic flow meter operates by alternatingly transmitting and receiving a burst of ultrasound between the two transducers by measuring the transit time, and it takes for sound to travel between the two transistors in both direction. From the figure we can see that the two transducers are there and an ultrasonic wave passes through it. So calculating the transit time between the ultrasonic wave which flows from these two transducers, we can measure the flow. Then we will talk about different miscellaneous instruments apart from the electrical measuring instrument, apart from temperature measuring instrument and the pressure. There are certain other instruments which measures different other parameters. Now, fire rate gas analyzer. So these instruments are used for measuring and analyzing carbon dioxide or oxygen present in the gases. It is the pyrite absorbing fluid is selective in the chemical absorption of carbon dioxide and oxygen. They are very fast and accurate and easy to use. In addition, they are unaffected by the presence of other gases. They will only absorb the carbon dioxide and the oxygen concentration. Next, we have combustion analyzer. Combustion analyzers are portable devices capable of estimating the combustion efficiencies of furnaces, boilers, and other fossil fuel burning machines. Now, two types are available like digital analyzer and manual combustion analysis kit. So, digital combustion analysis equipment performs the measurement and reads out combustion efficiency. So, these instruments are fairly complex and inexpensive. The manual combustion analysis kit is also there, and the